Hey everybody, welcome to another APA style results video. And this one, we are going to continue the series that I started, I don't know, a lot of many months ago with my correlations. And so in this video, we're going to do two t-tests APA results. We're going to do independent samples T, and then we're going to do a dependent samples T or a paired samples T. And here is my Word document that I'm going to be using to type all of this stuff out. Apologies in advance for typos and things that I don't catch as I'm typing, or if you get frustrated by my typing. So apologies for that. We're going to quickly go through doing the data for an independent samples T in Jamovi. I use Jamovi in my teaching, and so if you've seen the other videos on my channel, you will know that I use Jamovi, and I have tutorials of Jamovi throughout. So there's a video already on how to do all of this. I will try to link it in a little card up in the top right-hand corner, as you see in many YouTube videos. And so in this one, I'm going to try to link it to get the actual step-by-step guide on how to do all of this analysis. I'm just going to do it really quickly so we can spend the rest of the video on typing out the results. So this is the independent samples t-test example, and then we'll do a paired samples t-test, and we'll do the write-up for that. So, all right, let's quickly go through here. We go to t-tests, and we go to independent samples T, and we have a tutor. There are two tutors, Bernadette and Anastasia, and we're going to see how much better one person did versus the other as tutoring for grades on a statistic exam. So broadly speaking, we get the basic table that gives us our T value, which is this number here, 2.12, our degrees of freedom, 31, and our P value. Now, this is generally fine for APA style report. At least this is the T statistic information, but we want to go a little bit more than this to really help flesh out the entire result section for this particular case, independent samples T. So we're going to grab our effect size. Okay, so this is our Cohen's D, 0.74, pretty gigantic effect, pretty large effect, just under what Cohen suggested be the large of 0.8. Okay, I don't really necessarily need the confidence interval, but I can show you how you would put that in right next to the Cohen's D, which is nice. I also want my descriptives because I want to be able to report my ends. Okay, so how many people had Anastasia as a tutor and how many people had Bernadette, and then their means and their standard deviations, because APA requests reporting of descriptive statistics. So it's really important to do that. We don't necessarily need any other information here. And so I'm going to go in between this window and my Word document to get this information. To get us started for independent samples T, independent samples t-test, okay, the APA style for reporting the expression is just basically this, okay? So you go T, lowercase, as I've done so far, DF, okay, in parentheses, right next to T, no space. Space equals space because we want to give actual space between our characters. We don't want them all bunched up. We want to be able to make them readable. It's sort of, somebody I found, I don't know, 2 years ago, suggested that if we separate our characters in numerical expressions, it's like separating or putting a space in between our words. So when you have the equal sign here, and then, the number here, and then a comma, and then number, and then another comma, and then number, it kind of just looks like I'm writing it like this. I want to eat spaghetti, right? That's sort of the idea behind putting spaces in between our characters. I know maybe many of you haven't learned it that way, but I think this makes a readable version for numerical expressions in text, in prose body. Okay, I accidentally hit the A there. All right, so we've got T, we've got degrees of freedom, we've got the equal sign. This equals some number, okay, and it can be positive or negative because the distribution of T averages around 0, and it goes to positive infinity and negative infinity. That's the range, negative infinity to positive infinity. Then we're going to put a comma right after that number, okay? I usually do 2 decimal places, but that's all right. Then we're going to put lowercase p, okay, and I'm going to put, again, spaces around my equal sign, and this is going to equal a number, okay, and that number can either be an actual value, or I'm going to put in brackets here. P is less than 0.001, okay, because this is the alternative to writing what P is. In our particular independent samples t-test, we do have an actual P value of 0.043, so we are going to use this version here as opposed to P is less than 0.001. Then we're going to put a comma after that number, and we're going to put in Cohen's D. Oh, that's going to be Zoen. So Cohen's D, and that's a lowercase d, and we are going to put an equal in between that, and then that is going to equal a number, and then a period, or we end it in some fashion. I'm going to go ahead and make this 100, and we'll just make this as big as possible. 200%, I think, everyone. So this is an 18-point font, and this is in 20-point font. And yes, I'm using Calibri. Shoot me. If you want, I can change it to Times New Roman. Oh, look at that. Times New Roman. Everything looks serify. Everything has a serif now. All right. So let's put this all together. So that's the t-test expression. So let's make a result section paragraph. First, we want to start with an indent. Okay, just hit tab By default, it goes in half an inch. Okay, for my non-imperial system folks, I don't know how many centimeters that is. Half an inch, I don't know. A centimeter and a quarter, maybe? Something like that. Yeah, centimeter and a quarter. We'll do that. We'll do it that way. I don't. Can you even set? You must be able to set it as centimeters and not inches. I just haven't. I've never done that. There you go. There's the America-centric bias showing here. All right, so half an inch or a centimeter and a quarter. Okay, so let's talk about this. We got to set up the intro. So we're going to set up what this particular thing was. So we wanted to see whether or not the tutors improved people's grades and which tutor improved the person's in the class grade better, right? So did Anastasia help people more or did Bernadette help people more? And we'll find out. We'll find that out. So we're going to start here and see again, an independent samples t-test was, one important thing I forgot. We need to italicize. So what I'm going to do is I'm going to highlight one of my characters, then I'm going to hold down Command. I'm using a Mac, as you can see, but you can use Control if you're on Windows PC, and it will keep everything that you've highlighted that needs to be italicized highlighted, right? So I individually highlighted those while holding down Command or Control. Command for Mac, Control for Windows. Okay. And now I'm going to use my keyboard controls, or I can go up here and press the I button to make them italics. So Command I or Control I, or coming up here and pressing the italics button, okay? So then I'll make them all italics. That's because in APA style, Latin letters that represent statistics are italicized, okay? Nothing else was italicized, although you could italicize this P as well. All right, bada bing, bada boom. Okay, so an independent samples t-test, and then we'll italicize this T as well, was conducted, was conducted to determine if there was a difference between two tutors for a statistics class. Two tutors. And I'll put Anastasia and Bernadette. On grades, and instead of force in a statistics class. All right, so if there was a difference between two tutors, Anastasia and Bernadette, and then on grades, which is our DV, right? So we're going to see if there was a difference between our two different groups, okay, on grades. Now, I'm sure you could write this a little bit more classy, but I'm, of course, going for speed here. So this is just a rough sketch of how a result section might look like, okay? So students in the statistics class who had Anastasia, I can't spell, who had Anastasia as their tutor. We're going to do descriptives first, okay? Scored on average, and then we're going to go to our descriptives here, okay? In parentheses, I'm going to put in n, a lowercase n equals, and they had Anastasia, so 15, okay? 15, and we're going to put that in there, and then I'm going to italicize n. And what did they get? 74.5. 74.5 out of 100 on their stats exam. It's not a great average, got to tell you. But Bernadette is just kind of worse. While students who had Bernadette as their tutor, and you know what I'm going to do? This is where just copying and pasting is your friend. And we're going to change that to 18. I'll go back just to show you 18, right? Scored on average 69.1 out of 100 on their stats exams. Let's do that. All right, so we've got our means in there, right? So our means, or we can do M equals if we wanted to. I'll probably do M equals and standard deviations and parentheticals on the paired samples t-test just to show you the difference here. But I wanted to include the numbers in the grammar of the sentence, right? So the 74.5 out of 100 versus 69.1 out of 100, it's part of the grammar of the sentence, okay? But we're missing one crucial detail for these particular means, and that is their standard deviations. And we're going to put that next to the average in parentheses with the SD abbreviation. So SD equals, and then we're going to go back over here and we're going to look at our SDs, not our standard errors, but our standard deviations, 9 and then 5.77. So this one's easy, 9.00. And I always, let's add in, and I always do 2 decimal points, even if they're zeros. And you know what? I'm going to do that here as well. Okay. And then I want to italicize the S and the D. Okay. So if we grab that and we're going to copy it, and we're going to put it right after this, and we're going to change this to 5.77. Oops, I did too many parentheses. Perfect. There we go. So that is the descriptives for our particular independent samples t-test. Now let's add in the inferential bit, this inferential bit of information, okay? Because we need to close this out. We need to tell the reader whether or not this mean difference was statistically significant in our sample, 15 and 18 or 33 total students, right? So we can say that this was statistically significant. So this difference between earned grades on the stats exam was statistically, significant. And I always say statistically significant just to make sure that people don't read my use of the word significant to represent meaningful, right? This difference between earned grades on the stats exam sorry, I need to add the two tutors was statistically significant. And I could period this. This sentence makes sense. It's grammatical. It's probably not the best sentence, but again, I'm doing rough speed for accuracy, speed for formality trade-off here. But this sentence is grammatical. But instead of putting a period here, I'm actually going to put a comma, and then I'm going to addend the APA style expression to the end of this sentence. And I'm going to include it all here. So I've already italicized all of this. So I'm just going to go ahead and just do a substitute method here. And I'm going to plop that in here. And I'm going to go back to my output. And I'm going to plug all of these numbers in. So T, the degrees of freedom was 31. As you can see here, 31. Usually 0.0 I do not include unless I'm using some kind of non-parametric alternative that makes the degrees of freedom a non-whole number. But we're going to just do 31 here. And that's fine. You don't need to add decimal points if they're all there. Okay, so T of 31 tells us what distribution of T we're looking at. And then we're going to change the two hashtags there, or pound symbols, number symbols, to our statistic, 2.12. Okay, so we're going to put 2.12 here. And then we're going to go to P. I'm actually going to delete my brackets P here because we're not going to use it. Okay, and then we're going to put in, and I usually put in all 3 digits. I, generally speaking, do not truncate P to 2 decimal points. I usually include P as 3 decimal points. And the reason why I do that is P is generally shown in modern literature as 3 decimal points. And a lot of people don't present data that, is less, is more than 0.05. Null hypothesis statistical testing is, generally speaking, no good, not going to be accepted, for better or for worse in our publication practices. I don't like it, but usually speaking, these are pretty small p-values. So I usually just show all 3, and it's important here because this is, with our small sample size, borderline statistically significant. 0.043 is near 0.05, okay? So just be aware of that. And then Cohen's D, 0.74, I usually do 2 decimal points just for that. Again, my personal preference, I always do p-values as 3 digits and everything else as 2 decimal points. All right, now I said I was going to add in, so you could period this right here, and that would be completely fine. You could also put a leading 0 in front of Cohen's D if you really want to, because Cohen's D can be above 0, or excuse me, above 1. I usually do not put a preceding 0 in front of my p-values because p cannot be greater than 1. I suppose it could be 1, and sometimes people will report that, but I don't put a preceding 0 because the rule is preceding 0 only if it can go above 1, as far as I'm aware of that rule. If you want to comment down below that I'm wrong about that rule, that's totally fine. I probably won't change my practice. Just like the people who will not and refuse to delete that extra space in between their periods and next sentences. The 2 spacers versus the 1 spacers debate. 2 spacers are wrong, as I say, right? Preceding 0s here, that's the hill I die on. How about that? Not a hill that I will actually die on, but still. So I'll put that preceding 0 in front of Cohen's D. Now I could put this period here, right? And end the sentence, and we're done with this section. But I do want to add a confidence interval. And this is how you add confidence intervals. You add a bracket, so just a square bracket, and then you put CI. And interestingly enough, CI as a Latin abbreviation, Latin alphabet letter abbreviation, it's not italicized. And I'm curious as to why that is. Maybe somebody in the comments can let me know why this particular Latin, maybe because it represents a range and not an actual statistic. I don't know. But in any case, we're not actually going to do equals. We are going to put a colon. And in front of the CI, we are going to put 95. And then, oops, I accidentally hit F there. And then we're going to put a percent. Okay, so 95% confidence interval. And we are just going to show what these are. Okay, and I'm going to round this to negative 0.009. Okay, so it's not massive. Okay, 0.009. And then we're going to put a comma, because this represents the lower bound, and then the comma space. Don't forget your space. represents the upper bound. So 1.47, 1.47. And then we're going to close bracket. And then we're going to put our period. And that's the end of the sentence. Now, the confidence interval here is pretty shaky because it includes 0. And confidence intervals including 0 are suspect. Okay. Now, this technically includes 0 as it is mostly just 0. But yeah, this is pretty shaky. And the reason why this is occurring, the reason why this confidence interval includes 0 is because our sample is very, very underpowered. And it's just by virtue of the cooked books example that we got a 0.043 p-value here for the t statistic. Essentially, 2.12 as a t-value is fairly low. I think we're talking like 1.96 or 1 point something like that is sort of one of the critical values that we need to remember. So in any case, now this is an independent samples t-test, okay? I'm going to do a little bit of reset and we will come back with our paired samples t-test. I'll write it down here, paired samples t-test. Okay. All right, I will be right back. Okay, so here is the learning statistics with Jamovi. Again, I'll try to remember to put the card up in the top right so you could watch the full breakdown of this Chico data set from learning statistics with Jamovi. But in any case, what we're going to do for this is talk about our paired samples t-test. So we're going to just quickly do a paired samples t-test. Let me set this up for you. So in Professor Chico's class or Instructor Chico's class, we have 20 students, and we're going to see whether or not they improved or did not improve from test 1 to test 2. And so since we're talking about 2 sets of data for a single person, we're talking about paired data. And so we're going to do a paired samples t-test. So we go up to t-test, we go to paired samples t-test. And we are going to grab our 2 pairs, and we're just going to do that, and we're just going to do that. And what it does is it puts them on the same row. By default, we get, again, our test statistic, we get our degrees of freedom, and we get our p-value. And again, in this one, I get to use the other way that I mentioned using the t-test, okay? Now, again, I'm going to grab our effect size, okay? And I'm going to grab the confidence interval, and you're going to see a difference in the confidence interval here. And of course, I want my descriptive statistics. Now, n's not going to change. The amount of our sample isn't going to change because 20 are in each, okay? We don't need to worry about anything else in here. I don't need the plots because we're just going to put this in as a paired samples t-test in words. All right, so let's jump to it. Okay. Now, APA tile t-test expression is the exact same. We're just going to use that. Now, I believe the effect size is Cohen's D here, but I believe this is the Cohen's D adjusted for paired samples. My collaborator and I use Hedges G for paired samples, which is a modified Cohen's D, because Cohen's D was initially created by Jacob Cohen for independent samples t-tests. And so because paired samples t-tests are different in their calculation of the t statistic, D is different. Calculating D is different. But I believe the folks at Jamovi have made this the paired samples Cohen's D. So just be aware of that. You can use that. Otherwise, you would just change what this is. So for my writing collaborator, when we did paired samples t-test, we would put in Hedges and then lowercase g, and that's how it would work. So we are going to use the same expression here when we get down to the second part of this paragraph. So I'm going to leave all of that up so you can see the similarities and the differences between an independent samples t-test and a paired samples t-test. Now, the other thing that I recognized here is that you can put a hyphen in between independent and samples, or you can leave them as a space. I tend to not put. Although now that I think about it, I don't really know. I don't really remember what I've done. So just be aware of that. Not entirely sure. All right. So in this, I'm going to pretty much set up the paragraph in much the same way that I set up the previous paragraph. But we're not going to be talking about independent samples. We're going to be talking about paired samples. The paired can also be hyphenated like that. I don't know. I don't know. Maybe not. You could if you wanted to. Honestly, it's not a big deal. All right. So let's take a deep dive into this one. All right. So a paired samples t-test was conducted to determine if students in a statistics class improved or declined. Oops. There we go. Let's put that up there. From one test to the next. On test 1, students. Oh, actually, you know what? Since I want to use my M's and SD's in this one, the test revealed that students declined in their test performance from test 1, and then here I'm going to put in my parentheses equals. So my mean equals test 1 My mean was 57.0. I'm sorry, they improved. Sorry, improved. My bad. 57.00. And then standard deviation is 6.62. 6.62. And then we're going to close that parentheses. Now I'm going to highlight the M. I'm going to hold Command or Control, depending on what operating system you're using. And then I'm going to italicize those. And then I'm going to say to test 2. And then I'm going to copy the whole thing. And I'm going to paste it. And then I'm just going to change the values in here. And 58.4. So about a point and a half better. 58.40 and then 6.41. And this is where you get the big old effect, is because the variance was about the same on each test. And so that's why a point and a half shows such a gigantic effect. And then I'm just going to put a comma, and then I'm just going to add in the t-test expression here, like I did before, because I don't really need statistically improved. And then I'm just going to throw in some numbers here. So degrees of freedom was 19, because that's n minus 1. Okay, and then that equals a negative 6.48. And the reason why it's negative is because test 1 is the lower number than test 2, right? This mean is smaller than this mean, so we end up with a negative numerator. And then I'm going to put in p is less than 0.001, because that's what it is. Okay, and delete that. And then we're going to put in our Cohen's d, which is a negative 1.45. Now, Cohen's d can be represented as an absolute value. So 1.4, we can say Cohen's d is 1.45. Generally speaking, I like to match the sign from t over here to d over here. So if one's positive, then the other one's going to be positive. If one's negative, then the other one's going to be negative. You can represent Cohen's d as the absolute value, though, because it's symmetrical around 0. So you can do that if you'd like. And then we're going to put in our 95% CI, or confidence interval, and that equals our lower bound here of negative 2.07, and then a comma, negative 0.81 is what I'll do. Negative 0.81. And then close bracket, and then period. And then look at that. We're done. Amazing, right? And you can do either style for either one of these. So I could use a very short, quick, one-sentence style report for my independent samples t-test if I really wanted to. Let's put in our n. We can do a capital N or we can do a lowercase n. It doesn't really matter here because this is just one sample, but you can do that. Or we can change that to n. Yeah, let's do that. So n of 20 in a statistics class. Okay, and then so you can do a longer form for paired samples, or you can do a shorter form for independent samples. You can do either one of these for either one of these tests, which is really, really cool. Okay, really, really cool. And that's how you do t-tests in APA style results sections. If you have any comments, suggestions, or feedback, please leave those down in the comment section below. Hit me up on Twitter. Hit me up on Discord. Find me on Mastodon now. I'll put those links in the description down below. Thanks so much for watching. I'll see you next time. Bye.